Hi, and welcome to Best Guess Game Design. This is a series where I'm going to be looking at certain mechanics and structures within certain video games and trying to recreate them with Unity in the closest approximation I can make. Now, in all the cases, I haven't looked up how they've gone about doing anything. I haven't sort of read design documents or anything for these games. This is purely guessing how I would go about it, and I am by no means a master programmer, so there may be many simpler techniques and methods than the ones I use. But what we're going to do is try and look at these mechanics and what they can be used for. Now, the first one I'm going to start with is a game called Cultist Simulator, which has just come out on Steam. It's a narrative game where you are, playing a cultist. Now, what you do throughout this game is use cards, and the reason why I've chosen this one is because a little while ago I was thinking about a card game myself, and I'm a big fan of deck builder games. Now, for anyone that doesn't know, a deck builder game is a game where you start off with a small deck of cards, and as you go along you acquire more cards and take other cards out to kind of create your own little engine. Games like Dominion and Ascension did this in board games, but recently there's been another way of taking deck builder games with board games such as Clank, which is another game I personally quite enjoy, where the deck building isn't the whole game itself, it's just kind of the initial mechanic that you use. And then once you've built that deck, what you're using is you're manipulating it to go through a dungeon, so it's making you move or attack or various different things, which is a really clever way of using deck building. And there are similar video games that have done the same, like Slay the Spire, another game that's currently in early development, which is a deck builder. But what you're doing is, you're fighting monsters, you're going through it, and again, you're using this deck building mechanic just to move your way through the dungeon. So building the deck itself isn't the game, it's a part of it. You're using that to control a larger game, and I thought that's a fantastic idea. And the idea I had was for trying to do a Civ game, kind of like a 4X type thing, where you're able to manipulate what your deck does and how it does it, how many cards you draw, how many cards you can play, that sort of thing, based on what civilization you're building up. Do you develop technology, which might allow you to do X? Do you develop military, which might allow you to do Y? What I found in trying to think out this idea and kind of take notes on it is that even in early sort of thinking about it, working out the kind of number of cards you'd have in your hand became huge. And that was kind of a problem because no one wants to have to manage hundreds of cards at once per turn. It becomes too much of a decision, too much what's known sometimes in board games as AP, analysis paralysis, where you've got so many options of what you're doing that it's hard to think of one because you've got to weigh everyone up against the other one. Now, with Cultist Simulator, I think this addressed that problem really well. Even though I don't think a lot of people would describe Cultist Simulator as necessarily a deck building game. By not having a hand, by having all the cards in front of you, which is much closer to again, a board game term like a tableau. So there's games like Terraforming Mars, where again you're getting cards and you're using them to kind of build an engine in front of you by laying them down to allow you to then play more cards, to do more things, and throughout the game. So very much Cult Simulator is a lot like that. In that you're making this tableau of cards and then you're using them to interact, which I think is really a clever way to approach a narrative game in this one. But not necessarily only for a narrative game. Like I said, I think you could make a Civ game out of this. You could make lots of different types of games because what everything boils down to is just how the cards are played in what order. And what another very clever thing within this game is the time, the way you can use and manipulate and pause time, and the cards react to time, they degrade over time. There are certain of these squares, like this one here, has a time limit on it where every time it gets to 0, it uses one of your cards. So you have to constantly make sure you're generating these cards to be able to feed it. And if you run out, then it's game over, which is a fantastic structure rather than having just turns. And so what I wanted to do was kind of look at how I would go about recreating that. Now, what I don't want to do is try and make Cultist Simulator beat for beat, so I'm not going to try and copy everything. But I am going to be looking at the structure and how it can be implemented to be used for other games. And I needed a different theme. So the theme that we are going with is based a little bit around these squares. Now, these squares here, for anyone who hasn't played the game, they are basically, when you click on one, it brings up a little screen like this here, and then you place cards in it, and then when the timer runs out, it might spit out more cards, and it might not. It does various things. So what I came to refer to these as is cauldrons. You throw ingredients out and you get something else. Now, that I think is, again, it's another really clever mechanic, and it's what is kind of inspired the theme we're going to build this version of it around, because it's very similar to games like Doodle God, where you combine two things together to create something else. Crafting games in many ways, or as I've often referred to them, it's alchemy games, because a lot of time you don't know what combining those elements is going to result in. So it's a bit of an experiment. So the game we are going to make is going to be Cultist Simulator. So we're going to take these principles from Cultist Simulator, and we're going to see about recreating them. Now, one thing I'm going to do is I'm going to do this largely within Unity's UI framework. So we're going to have to do a few different things to manipulate that along the way, but we'll cover that as we do each of them. But I've created a project, I've started up, haven't done too much to it yet. Now we have a canvas, which you're always going to use with a any sort of UI within Unity, and within that I've just got a little title you can see there, and I've created some folders where I've got some art for use, I've got some fonts, got the material, which is just this skybox to make it a bit darker. Prefab, I've already created a card, which we'll get to in a second. Got some scenes, which is just this scene here, and a couple of scripts, although at the moment the scripts are pretty much empty. They've got a few things in, and again, we'll get there in a moment. And Text Mesh Pro, which is just to make any sort of text we put on the cards just come across a lot crisper and cleaner. So the game, as I said, it's going to be mainly UI based. So that means that we need to have a really solid way of how to manipulate UI. So what does Cultist Simulator do? Now, Cultist Simulator, a lot of people might look at it and not think that there's much going on UI-wise. That, because there's such free reign in it, you kind of place anything anywhere. And actually, that to me is one of the game's strengths and one of the best UI decisions it has, because whenever you're looking at a game and creating a game, you're really thinking about how are people going to interpret information, where's going to be the best place to put things, where's going to be, how do I keep this in the player's eye line so they don't forget about it, or how do I sneak up on them with this. And with Cultist Simulator, what it does really cleverly is you as the player kind of decide your own UI. You can move things everywhere. So it's giving the player that freedom. However, it also gives it a few restrictions to build that around, and it does some really interesting things. So, and that's another element that we're going to take from this. It's not just, the card cauldron aspect. It's that kind of free UI element. So how are we going to go about doing that? Well, so what we're going to do is borrow a lot of design elements from Cultist Simulator. For a start, let's look at the table and the board setup. I actually think that's a really solid setup, and so we're going to be using that. And so we are still going to be doing it within UI. So if we go to Unity's UI, it's going to pose its own form of challenges. If these were game objects, we'd be able to zoom in, zoom out, move the camera around to kind of mimic what Cultist Simulator does. Because we're using the UI system, we're going to have to be a little bit different with it. So we're going to be using the scale and the transform positions to give the impression of zooming in, zooming out, and moving a board around. But let's create a hierarchy kind of in the vein of that image. And so the first thing we're going to do is create a panel. We're going to rename this panel to table, and let's move the title so it's in front of it. And we don't want this to be stretched across the whole screen, so what we're going to do is give it a size, so 600 by 1200, and then on the table we're going to place another panel, which is going to be renamed to board. Now this one we actually have an image for, so I've created a little playmat image which we're going to bring fully into view. and we are going to remove the image from the table, because at the moment we don't need a image on it. So if we look at the scene, we've got a little play map that we're using there. Now you'll notice that the shape I've given it is kind of a trapezium. This isn't an effect done by the UI, this is the shape of it, to kind of give the impression of depth, and I'll cover why I think that's important a little bit later on. So on this board, we're actually going to bring in one of our prefabs. So let's play this on the board, and you can have a first look at it, and let's zoom in. So this is our card, very similar to the style used in Cultist Simulator. So again, we're not going to try and rewrite the wheel here. We are going to kind of take what we can. So with the card, we want to be able to move that around. We want to be able to also give the board the impression that we're moving our camera around the board. So to do both of those things, we're going to use a drag and drop script. So I'm going to place that on the board, and we're going to be using the exact same script for all of our objects. So what that means is we're not going to have each individual one having its own written rules of dragging and dropping. We are going to just simply use one script, so we can kind of create a set of rules that everything's going to live by. So let's go to our drag and a drop script. So it's set up using the event system, and because of that we have added in, on top of mono behavior, the iBegin drag handler, iEnd drag handler, and iDrag handler. And in order for those to be active, we need to have onBegin drag, onDrag, and onEnd drag, which each take the pointer event data. So this is all the data related to where the mouse is at the time, what it's hovering over, what it's doing, and we want to use that information. So what we want to do is we want to move whatever object is being dragged to the same position as the mouse, and that's relatively easy to do. We take the transform and we take its position, and we equal our event data dot position, and it's really that simple. The only trouble that's going to have is it's going to be a bit jumpy. You see, we might not be dragging everything from the center, and the transform position takes place from the pivot point. So what we want to do is we want to create an offset. So this is going to be, getting the capitals right, a vector 2, which we're going to call offset. And we are going to generate this every time we click on something. So offset is going to equal a new vector 2, and we're going to take the transform position x, and we're going to take away from it the event data dot position dot x, and then we're going to copy and paste, except we're going to change it to the y. So now we have this vector 2, which is storing the difference between where we've clicked and where the position of the item is. So what we're going to do is add this to our event data position. And now if we hit file, save, we should have no errors. Let's check the console. No, so that's fine. So let's go and have a look at our game. Oh. So let's press play. And now we've got this board here, and yeah, we can move our card around. And we can also move our board around to kind of give the impression that the camera is moving around the board. So that's great. That's a fantastic start, but also it's kind of hard to see the cards. And another thing that the Cultist Simulator had was you'd be able to zoom in. So how are we going to do zoom without a camera? Well, as I mentioned earlier, we're going to use scale. So the scale is going to be done in our table manager. Now at the moment, the table manager isn't attached to anything, but it will be. And we are going to attach it to the table itself. So we might make this do a few other things later, but for the moment, we want this to handle the zoom. So what we've got at the moment is, this is a really simple singleton pattern that I've picked up. It just means that we can, if needs be, we can access what's going on with the table manager from anything, depending what we put in the table manager later. And I am going to be putting some of the time elements in the table manager later, so that's why I've made this something that we can access from anywhere by just writing table manager.main. So we want to zoom in and we want to zoom out. So we're going to create some public voids to do that, just in case we want to do it from other functions as well. So public void, zoom in. There we go. Zoom out. And let's get a reset so it becomes the base one that you start with. And we're going to find that they're going to be doing kind of the same thing. So rather than doing it in both, we're going to have a void that only they can use, which is going to be, let's call it the zoom function. So the first thing we want is a public float, and we're going to call this zoom. So what the zoom function is going to do is it's going to make whatever the level of zoom is the scale. So where do we want to start this? Well, I actually think we want to start a bit more zoomed in than we are. So let's do zoom equals 2, and then zoom function. Actually, let's not do zoom function. And let's write what zoom function does. So zoom function is going to make the table scale what we need it to be. So the table, we're going to have accessible from this. So we're going to have a public transform that we can drop the table into, and we'll call that table. So what we're going to do is table dot local scale equals zoom, except that it does not like that. Why? Well, the local scale is a vector 3, so what we're going to make it equal instead of zoom is a new vector 3 that is zoom, zoom, zoom. So now it's going to change all aspects of the local scale to match. So zoom in. So zoom in, we need it to be bigger. So that means we're going to increase our zoom. So when we zoom in, we want zoom to plus equal 0.2 more. But we don't want to zoom in too much because otherwise it becomes too big. So we're going to set that a limit by just doing if zoom is greater than 3, then zoom equals 3. So that's fairly simple enough. And now we're going to do exactly the same thing, except it's going to be zooming out. We're going to make things smaller. But again, we don't want to zoom out too much, so we're going to do, say, 0.5. And now we have our zoom function. And to reset, we'll just have zoom equals 2. and then we want everything to run the zoom function. So again, it's not a complicated system we're trying to put in. We're trying to keep everything as simple as possible. But now we need to have this system actually run and work. So how are we going to do that? Well, let's keep it as simple as possible. And the very standard way of zooming in games and zooming out is using the mouse scroll wheel. So why reinvent the wheel if you don't have to? And so let's do an update, and we are going to need to look out for the details from the mouse wheel. So what we want to do is find out which direction it's gone in. So to do that, we're going to get the axis of it. Obviously, if it's a positive axis, it means it's gone forward. If it's a negative axis, it means it's gone back. So what we're going to do is we're going to have an if statement. We are going to get the axis, which is called mouse scroll wheel with 3 capitals, very important. We're going to times that by 10 just to make it a bit more readable, and then we're going to see if that is bigger than 0. And if it is larger than 0, so if it's positive, then we're going to go forward. By going zoom in. However, we don't want it to just zoom in or anything else. We do want another if statement, but we don't want it to, for any reason, accidentally do the same thing, do it both for the same frame. So it shouldn't, but just to be a failsafe, we use an else. That way we know that that definitely won't happen. Well, we're not going to reinvent the wheel here. What we're going to do is use the mouse scroll wheel. It's a very standard for a lot of games that controls the zoom. So to get that information, we're going to do an update, and then we are going to listen out for it. So what we're going to listen out for is the input. We're going to get axis, and we're going to do capital M. And we're going to ask, is it greater than 0? If it is, well, then we're going to zoom in. But if it's 0, we're going to do nothing. And let's copy this. So for 0, we'll do nothing. But else, if it's less than 0, it means we've moved the scroll wheel backwards, and we're going to zoom out. So let's make sure we've got the right endings on. As you can see, we've got the warnings there, and we'll save. And now if we go back to our project, we're going to press play. And we can move the card, we can move the table, we can zoom out, we can zoom in. So that's going to give us a lot of freedom to manipulate where and how we manage the UI. So what we're going to do is add a second card to this. So let's add this. And now we're going to have a look here. See, if we move this card, it's absolutely fine. It's in the front. But this card is behind it, and that looks kind of bad. So one of the last things we're going to do is just create a method to prevent that from happening. So our table at the moment has just a board in it. What we're going to do is we're going to add an empty, and we're going to rename this to active almost put card, but it's not going to be just cards we do this with, it's going to be active object. So, what's the active object for? What we're going to do is whenever we pick up a card or a cauldron, we want it to jump into the active object. So the best place for us to keep track of this, rather than being in, say, the table script, is going to be within this drag and drop. So we're going to need a few public factors for it. So let's go to the drag and drop script. So what we want is a public transform, which is going to be active object holder. We also want a non-public transform called current parent. I'm not a great typer. And what we're going to do is, simply enough, when we start dragging object, we're going to go transform dot set parent to active object holder, and right down we're going to do it to current parent. Now, before we change it, we're going to make the current parent equal the transform parent. Now we have a small problem with this. Because we're using our drag and drop for pretty much everything, we don't necessarily want everything to become active and brought to the front. We don't want the board to do it. So the best way for us to do that, again, we could create different scripts, but we want to do it within one. So what we're going to do is we're going to create a way of telling them apart, and we're going to do this with an enum called object type. And the object types we're going to have are going to be board, cauldron, card, and there's one more that I won't get to just yet, but for a later episode, which is going to be dispenser. And those are going to be the types. So the next thing we need to do is give it one of those object types. So public object type, and we're going to call this underscore type. So we only want this to happen if it is not a board. So if underscore type does not equal, let's do this properly, object type dot board, then we're going to do this. And same thing for when we reset the layer later. Now that's going to be quite useful in the long run, because there's going to be other functions that maybe only exist within one or the other. So as an example, we're going to have an outline, and this is something I want to do now. One thing you want to be able to do is to highlight objects when you pick them up. That way it's really easy for the player to definitely distinguish which is which, especially if a function you might use is to disable the cursor when you are dragging things around, because sometimes when the cursor is moving at a different speed to the object you're dragging, it doesn't look great. So disabling the cursor is a way of fixing that. So when you do that, you definitely want to be able to highlight which is being dragged. So we're going to add a game object, So public game object, and we're going to call this outline. And so again, if we have an item that's not a board, when it starts getting dragged, the outline, we are going to turn on. And equally, when we drop something down, the outline we're going to turn off. So let's save that and let's now go look at our objects. So we've got our table, which is currently, let's start off with a zoom of 0, and let's start that off with a zoom of 2, and we will change its scale to be 2, 2, and 2. Ooh, I've got a typo. Let me have a look at that. Have I? My bad. That is fixed now. Let's have a look. Yeah, accidental capitalization happens time to time. So now our zoom is going to start in at 2, and we've got a table. So with the board, let's look at the board script. So the board, it says it's a board. Now the active object holder, we'll put in there just for consistency's sake, but there's no outline, so we don't have to worry about that. Now let's look at our card templates. So it's currently set as a board. That's not great, so let's set it as card. Let's make the active object holder the active object, and the outline, well, we're going to make it this handy outline that we already have attached there. As you see, I've already gone to the effort of creating this, so there's a few things on this we will get to at a later point. I'm also going to take that off while we don't need it. Oh, that's right. There we go. And what we're going to do is just apply these changes we've made to all card types. And now let's look what happens when we move things around. So we already start off zoomed in, and we can zoom out. So we move one card over here, and look, there's our yellow outline. There's a yellow outline there, and look, whatever card you're dragging is now, because the active outline is on top, is now over the other one. So that's kind of where I'm going to end the first episode. We've got a great start in place, but there's a few other things that we are going to do. And the next episode, we're going to look at creating ways of handling the cards, and we're going to create the time and how the cards react to time. We're also going to put a few more tricks in place for making this a little bit easier on the player to manipulate. Now, one of the things that I think is really clever within Cultist Simulator is this trapezium map, the kind of depth it suggests. Because here's the thing, when you give someone complete free reign over a UI, they could do anything with it, but you want certain things to be important to them and a way of organizing it. And by giving this kind of depth, it naturally means that when you're sorting things, you know, this feels like it's closer to you than that card. So that card feels more important than that one, which it's not. It's the same size. It's the same, you know, it's no different from where it's being placed, but just that slight angle to the image makes that card down the bottom feel close, and therefore gives you somewhere you can put things that are important. So we're going to look at how we guide the player's eye with a few UI features, and we're going to also add in a little function that's going to change the scale of the card slightly. So when they get placed at the back, they get a little bit smaller, and when they place the front, they get a little bit bigger. Not for anything more than just kind of an aesthetic way, and for making the player kind of judge the importance of where they place stuff. But this is the end of the first episode. I hope that you enjoyed it. Again, there might not have been much new in this episode. A lot of stuff we did was very basic for getting the setup, but hopefully as the series goes on, what we do is going to get a little more interesting. We're going to get the handling of the cards down, we're going to get the handling of the cauldrons down, and then we're going to start working out, well, how do we fill those with data? How do we create a game from within that? But thank you very much if you followed the whole video. It was great talking to you. I'll hopefully have another one up very soon.